I'm Aleksander Bartoszewski. Personally I'm architect. I'm representative of Prochem. Prochem is large company from AIC industry. Also, we are specializing in BIM technology in AIC industry. And in BIM4EEB project, we are the work package 8 leaders, which is related with demonstration of toolkit which was created during the project on the pilot sites. The beginning, short information about today's workshop agenda. So the workshop, it will last 2 hours, and in the beginning there will be some introduction part. In the second point, we will present you the Polish pilot case. And in the third part, there will be presentation of tools demonstrated in the Polish case, and it will be hosted by each toolkit owners, which is BIMS platform Davide Madedu from one team. This is Italian company from IT business. Fast mapping toolkit will be presented by Iva Lotta from RISE Research Institute, and BIM4 occupants will be the presentation will be done by Kostas from Suite 5. Also, this is company who is more like IT from IT the department, and BIMS-CPD. In the end, we have the BIMS-CPD presentation. It will be provided by UCC, which is Technical University of Cork from Ireland. So it will be a very interesting part for people who are new on this project, and the presentation will finalize. After the presentation, we will finalize with short surveys collection. It will be online survey, so I will send you. I will use the chat feature, and I will send you the link for the survey. And this is very important for us that you will participate in this point, because it is also very important from the project point of view to get your feedback. And after that, there will be some time for conclusions, questions, and some kind of summary of today's workshop. So welcome everybody again. Welcome from Poland. I know that we have some guests from Poland, Italy, other countries. So we are very happy that you managed to join today's workshop. In the beginning, some short introduction, general introduction about the BIM4EEB project. This is UA-funded research project, and it is the duration of the project is about 42 months. It have started in January 2019, and it will last till June this year, which is 2022. The project is in the project we have the consortium. The consortium is presented by 15 partners from many countries, European countries. So we have representative of European northern countries, Sweden, Finland. We have Ireland, Germany, Poland, of course. And from south side of the Europe, we have Italy, Spain, Cyprus, and Belgium, or in the Central Europe. So basically, we have 3 universities, which is BIMFOREEB, this is Technical University from Milan, UCC, this is University of Cork, Ireland, and TUD, this is Technical University from Dresden. We have also 2 research institutes, which is VTT RISE. They are from Sweden. Also, we have representatives of 2 public administration from Italy, which is Lombardy, region Lombardy and Aller. 4 startups and small medium enterprises, which is Solintel, Suite 5, One Team, Visual Link, and 3 large enterprises. There is Caverion, also large company from AIC industry from Finland. We have CGI from Sweden, and of course Prochem from Poland. And in the end, there is also one EU association, which is ACE. So, like you can notice, this is multi-language and I would say multi-country work. It is very interesting in such point of view. Okay, on today's meeting, there is also Professor Bruno Danotti with us. He is a representative of BIMFOREEB, Technical University of Milan. I will give him a floor to present us the general objectives of the project. Bruno, can you hear us?
Yes, yes. Can you hear me?
Yes, yes.
Hi. Thank you, Alexander. Thank you to Prochem to invite me for this workshop. And of course, thanks to Poland. I was available to come to Poland, but I discovered that finally I was the only one. I don't know why, but maybe I will succeed to come to Poland. Well,
yes, you are very welcome.
Well, about the general objective of the project, the point is to develop a BIM-based toolkit for efficient building renovation. So the focus is, of course, considering residential buildings. And upon this asset, the idea is to develop a set of tools which may, let's say, help the stakeholders to manage the different stages of the renovation process. So, as you see from the first sentence, the toolkit wants to increase the efficiency in the management of information, decrease working time and costs, we will see later. But of course, there is a general goal, which is improving building performances, quality, and comfort for inhabitants. I've seen that today we will see also fast mapping and BIM4 occupants, and both of these are useful. The first for, let's say, having some support in generating the 3D model, so the BIM model, and BIM4 occupants developed by Suite 5 to support the involvement of the inhabitants. Then, as I was saying, at first, the first point, if we don't have any model about the building, the first issue is to reconstruct the 3D digital model of existing buildings. In this direction, the work developed in Sweden by RISE and CGI is important to create the model in an interoperable format, IFC model based on the ISO standard. And that's the basic point, just to have a first model. We will see later also a very interesting device developed by in Sweden, also to know about what is inside the walls, some studs, tubes and lines, not only what is seen. Then, what we in the last sentence we mentioned the guidelines. The guidelines we are developing this at this moment in BIMFOREEB with Region Lombardy and also private partners. The focus is to start speaking about how to implement BIM, because you know BIM is some years that everybody is using, but the problem is how to use the information modeling, and not only rendering, is not CAD, but managing the information throughout the process. So involving the stakeholders and at first defining which are the information requirements, the information needs, and the workflow. So the flow of information among the different stakeholders. Then we will see very, very important is the common data environment, which is based on the international standard ISO 19650, which has been developed in the platform. The BIM management system, you will see later with the help of Davide Madedo from one team. And there, of course, is the, let's say, the heart of the toolkit in the center, managing the different tools. I don't know if you have other slides or it's up to you, Jaroslav.
Yes, so Bruno, I can follow the slides. Yeah, thank you very much, Bruno. Bruno is of course, our project coordinator. So thank you very much for the
You're welcome.
Sentences about the general objectives.
Thank you, Alexander, and also Jaroslav. See you.
Thank you very much, Bruno. Okay, so what was our overall work plan? Overall work plan. So basically, our project was divided into 3 phases. Phase 1, 2, and 3. In these days, we are in phase 3. We are finalizing the project, but there was a lot of job done during the phase 1 and 2. Of course, we have started with phase 1, which was to gather the requirements from the, I would say, end users. Also, some technical research about the linked data and ontologies was done. After that, technical partners have created the toolkit. A few tools, and they are also related with themselves. So after that, after gathering the requirements from end users, the toolkit was created, and in the end, the phase 3 is to demonstrate the toolkit on the 3 demo sites picked for the project. I would say the best representatives of different climate scenarios. So we have Italian pilot site, which is South Europe. We have the Finnish demo site, which is the North Europe, and of course Poland, like a Central Europe country. This is the graph for the toolkit. So in the third part of the workshop, there will be presentation related to toolkit, which was demonstrated on the Polish pilot case. But anyway, so this is the whole toolkit. So we have I would say, the central CDE platform, which is BIMS platform, BIM management system. We have fast mapping of buildings, which is for the very innovative inventory procedure. We have also BIM-CPD, BIM Easier, and Authoring. These platforms are more related with design stage. And we have BIM Planner for I would say renovation works management, and for the end user, for end users, for the occupants, we have also BIM for occupants, and this platform will be also presented in the third part. So in the Polish case, we have tested the BIMS platform, fast mapping of building, BIMS CPD and Auteras, and BIM for occupants. Okay, we can go to the second part. I will present the Polish site, Polish building. So the location is in Chorzów. Chorzów is nearby Katowice. It's on the south side of Poland. This building is the oldest one from the three that was from the three buildings which was included in the BIM4EEB project. So we have very old building, residential building. It was built in 1902. It has 5 floors, and including 12 apartments and 3 commercial areas on the ground floor. We have a few pictures from inside. So we have the main entrance, the main stair core, and you can also notice the electric meters shaft on the main stair core. So like I mentioned previously, the building is quite old, and so it's typically the building is quite typically for the buildings inside city centers that will need to be renovated in the future times. Okay, what was the scope of the demonstration activities? In the beginning, to fulfill the project requirements, we had to install a set of sensors inside the apartments which joined the BIM4EEB project to measure conditions inside conditions. And then this measurements was translated into our platform, and then we could assess the special indicators to show the result of the project. So basically, in the Polish case, we used this setup from the graph. So we have the central hub in the middle. With the hub, there is mainly two sensors for the temperature, relative humidity, occupancy, luminance connected, and of course we have sensors for the electric energy meters. All of these sensors are connected to the central hub, and then after that, with API help, it is transferred to our central BIMS platform, which is BIMS, the central, which is CDE. And of course, for the project purpose, we had to use also the heating energy meters measurements to assess our project indicators in the final stage. You can notice some pictures from the installation. So we have different, of course, we have different apartments, different people, different size of apartments, and we have additional requirements from them. Additional requirements also about the placement of the equipment. But anyway, the inhabitants from the buildings were very helpful for us, and I think it was very interesting from their point of view to be part of such interesting European project. So after the installation of the sensors, we could follow this is the setup for the Polish case of the sensors. So we have mostly we have sensors in living rooms and bedrooms. And after that, after the installation was finalized, we could start to demonstrate the tools on the Polish pilot site. In the third part of the workshop, there will be deeper presentation of each tool, but just to give you a notice, the central platform is using the sensors data integrated in it, and for the renovation scenarios, we can use it easily by accessing the platform. Also, BIM for occupants and BIM-CPD is using the stream data from the sensors. Additionally, for BIM for occupants, which is the platform for the inhabitants, we managed to provide dedicated workshop for each inhabitants to show the possibilities of the platform and make them easier to take part in the project, because we are using the results, the end users feedback to assess the major indicators of the project. And also in the Polish building, we have tested the very innovative toolkit, I would say, for the inventory stage, not only for inventory stage, but mainly I would say for inventory stage, which is fast mapping toolkit. Eva in the next part will present this in detail, but it's very interesting, and it's using the laser scanning, and with importing to HoloLens, you can do, I would say, 3D inventory inside the virtual world. So I think this is the last slide in this part. Do you have any comments on this stage? So I think we are in time, and on this part, I will ask Davide from one team to present the BIMS platform. Davide, the floor is yours. Do you hear us?
Yeah. Good afternoon, everyone. I share now my presentation. Okay, do you see my screen, I think?
Yes.
Okay, perfect. I leave out my webcam just to optimize the stream. Okay, the BIM management system, as see before, is basically the central part of the toolkit of the tools developed in the project. Basically, the main goal of the BIM management system is to optimize the information management, optimize how the data is managed, because we know that in buildings the data is so much, the life cycle is very complex, and if we do a poor management, this could hinder strategic decision and also the collaboration between parties. And for this point of view, the BIM management system works as a common data environment. It is something like a buzzword of its times, because it's an environment where all the information is collected, managed, and at the same time with the information container could be shared for every stakeholder in an easy way. And we developed from scratch completed common data environment. This is the first stage when you enter and log in to the system. And yeah, the main goals are to support all the stakeholders, that is multi-user, starting from the inhabitants, owners, and also designers, until local authorities, for example, where all the people can save models and documents regarding designs and also building, and also store live data on sites, for example, measurements from IoT devices, and also collect the feedbacks from inhabitants that can provide a wide perception of needs, and these feedbacks could be collected with the integration of the all toolkits from the other tools. The BIM management system is deployed in a server over the internet. Obviously, you need a login because the data inside could be some personal data, because measurements, buildings, apartments. And one of the things that you can do is to upload things, make permissions and share with some other users, and also take trace of the revisions, because a document could be multiple revisions, and that can also shared in a different way, for example, for different teams that are working on, I don't know, for example, in architectural side, engineering side, or maybe also to publish some data for the owners or directly to the inhabitants. As you see, there is the interface of the common data environment. That is something like an advanced file system where you can put some things. Here you can see another important functionality is that if we manage data of the buildings, one of the best things to do is to create a BIM model and share model with the design teams, but also with the end users. And this is the interface of the BIM viewer, where you can see the model of the Polish demonstration site. You see on the left side there is the hierarchy of the BIM model with you can select in 3D or in the hierarchy any element of the 3D model and see the properties. And also another important thing is that there are some functionalities that support the possibility to locate geographically the resources, for example, the model, but also any kind of resource like a document or anything. And this is the screenshot that you see some locations of the resources in a Polish demonstration site, starting from you see which is the weather information, but also going down in the right side panel, where you can see some information about the nearest important buildings that are nearest the main building, the demonstration site. For example, in these functionalities, you can ask to the platform to give you all the important buildings that are located around the point where is your building. And you can see these buildings categorized by different users. For example, there are church or institutional buildings. And if you can select one of them, you can get all the information that can be collected from, for example, from Wikidata. Wikidata is an important database that stores all the data of Wikipedia. And these functionalities can be used, for example, for the design to get information about what is the nearest buildings near your design. And this could be used for example, to design. We talked about IoT, talked about sensors, and here is the data that will be collected from inside apartments. Some apartments can be used as a demonstration. We put sensors, and in the BIM management system can be stored all the measurements to be recorded and analyzed by other tools, like for example BIM-CDE and some others that you see after my presentation. And this data could be also viewed in a way that could be selected in 3D, the space where you get the details of the sensor installed and also the measurements. This could be very, very helpful for a user to select visually where is the sensor and which is the measurement. And another important thing is that as a common data environment, we store the documents, but we need to classify these documents to better filter and to better have identification for which is the typology and category of the document, and also to make links between documentation. And also, when you store something, you can also add what we call linked data. Linked data is an important technology that is very, very powerful, that can allow to link, as the name says, linked data, to links any other data that can be find in other servers or other resources over the internet, and you can link this data between them, and also give, as we see before, the location, to give a geographical location of where your data is. And all these things are recorded in terms also that you can see the history of your document, where you can see which version is the document, when it is created, this document, and which is the people that are edited the document, and basically adding also comments about that. And this is important to see which is the user that done something and share something with someone. And finally, about which kind of data can be put inside BIM management system, we see that we can put BIM models, basically from IFC interoperability format, but also you can put inside any kind of documents, like for example, Office documents, PDFs, Excel file, PowerPoints, images, and others. An important thing is that when you work with a team, it's important that some things can be approved, and also in an approval way, you can create some workflows where you can invite someone to approve some resources, and when the resource is approved, this can be shared and also published. Is something that is very, very common in design workflow, and this could be done in the BIM management system. Yeah, we have not so much time to explain very well all the functionalities, but just to say that here there's a small video where you see what are the kinds of activities that can be done by the user. For example, creating resources, uploading the documents inside, viewing all the details. And we can think that, for example, that is another user that can log in to the system and also share their things, and make an approval workflow for get the information, feedbacks about the documentation. All the workflows and all the data and the things, functionalities are completely compliant with the newly BIM standards, that is ISO standards. Another important thing that you see now in the system, that there's some things that you can upload or some activities that you done in a BIM management system. There are the functionalities that inform the user by email about the changes inside the BIM management system. Another important functionality is the building logbook, that is another buzzword in this topic, that is a functionality that can allow to the, for example, for the owner to have every information about the building, starting from the documents or anything that happened in the document, completely stored inside the BIM management system. This could be helpful in operations during the life cycle of the building. And the last but not least is the linked data spatial endpoint that allow to the registered users to access to the data stored in the BIM management system in forms of linked data. Basically, we use the linked data that are stored outside the BIM management system to retrieve some information, like the example before about the Wikipedia. But also the data stored in the BIM management system can be also shared outside, giving a Sparkwell endpoint, a public Sparkwell endpoint, to give to any registered user to access the data inside. As we see, is another example on how to use linked data. We can retrieve and share data to make some comparison or replacing something inside. An important thing that just to conclude about the functionalities and the results of using the BIM management system, we elaborated some functionalities that allow, for example, to store the data of the BIM model. As you know, the BIM model are sometimes very complex. Sometimes is time-consuming creating information in the BIM models. And the traditional way is sometimes bottleneck in upload, download. When you create something in the model, you change something, you have to upload the BIM model, and when you share with someone, these people have to download, and these continuing upload, download in the design chain is something bottleneck. And we create a system that instead to upload, download the files to share the data, we use the REST API, where all the data that is not geometrical data can be shared using the REST API with the post and get methods to just exchange the data. These allow to save more than 17% in time reduction and allow to get the design phase more fast than before. And we tried that with some things in IFC, and we want to expand. And also, finally, we elaborate systems that can connect the BIM management system with the other tools, first with the tools that you see in the presentation of today about the toolkit of the BIM4EEB toolkit, but also other external tools like also BIM Authoring tool, existing BIM Authoring tools, planning tools, and every tool that can allow to get embossed data using APIs. And this could be very interesting because allow to exchange data in a centralized way, in a more efficient way. And yeah, just this is an example of using one of the most used authoring tool in the market, where you retrieve, for example, data from the BIM management system, from sensors, and getting the graph of the temperature, for example, or also creating some things inside the BIM authoring tool. This is an example in this video of creating, for example, spaces or some subdivisions inside the BIM authoring, and post these changes in the IFC model that is already stored in the BIM management system. And using the REST API, we create a very fast changing in the model, avoiding repeating download and upload files that can be more time consuming. Yeah, is the last slide, and I will thank you for the attention.
Thank you very much, Davide, again, for your very nice presentation. I will ask Eva Lotta from RISE to present the fast mapping toolkit.
Yes, thank you, Alexander.
Yes, the floor is yours.
Okay. So I'm going to present the mapping tool, which is a part in this project. Me myself, I work at the Research Institute in Sweden. I'm located in the south part, Borås. And the tool that I'm going to present today is called Fast Mapping Tool, and it's one part of the toolkit where you already have got an introduction from. This Fast Mapping Toolkit has an object, and that is to easier obtain documentation of the construction of the existing buildings. To put in the BIMS platform that you already have seen, you need to have the geometry and the structure of the building. And this tool is to easier obtain this information, and also to get more information, not only the geometrical information of the building, but also some information about the building status and also its construction. And by having this in a 3D dimensional model, it's easier to understand what you have and how the building look like. So how is this possible, and how will this toolkit, how will it works? The first step is to scan the apartment or the room with a laser scanner. This is a commercial tool that already exists on the market. On the picture here, you can see my colleague Jörgen. He is around a lot in Sweden and also in other countries to do those kind of 3D scannings of different buildings, different rooms, and other constructions. The scanning creates a point cloud. That is what you can see in the left corner of this picture. The point cloud is the geometrical visual structure of the room and the building, and it's in 3-dimensional, so it's possible to turn it around and look how it looked like inside and around. What this is the point cloud. It doesn't give any real information. The computer or the point cloud don't know what's a wall, if it's a wall or if it's a window or something else. It's just points. So the smart thing with this toolkit is to use AR glasses, augmented reality glasses, and those glasses makes it possible to see both the point cloud and the reality at the same time. If you haven't used any kind of those glasses before, I can say that those glasses, they are fully transparent. So when you wear them, you see just the ordinary reality as it is. And this toolkit makes it possible to download the point cloud into those glasses. So when you wear the glasses, you can see both the reality, like through the transparent glasses, but you can also see the point cloud. So on the left figure in the picture, left down, you can see this is a part of an office room. You can see the cable channel, and it's some black box on it. To the right in the figure, there is only the reality, and to the left you can see the point cloud on, if I say it again, like the reality. They are aligning to each other. So on the glasses you can see both the point cloud and the reality at the same time. But I also told you that this toolkit should give you more information and just the geometry. Because when you have the point cloud in the glasses, it's possible with your normal finger to click the corners of the point cloud and define it and say that this is a wall, and click the corners and say that this is a ceiling, this is a floor, and this is a window. And then the computer knows what it is, and it could create an IFC file of it. But now back to the more information is that also to those AR glasses, a sensor stick is connected. That's what you see to the right upper in this picture. And this sensor stick contains small meters, which are in the white box there. And those sensors, they are, say, like normally sensors that you can buy in a construction store or something. They measure capacitance and inductance. By measure those characteristics, you can detect if there is moist or water pipes within the wall, because the sensors measures the different in like if I say density and also the resistance of what's inside the wall. So by measure capacitance and inductance, it's possible to detect if there is studs or anything, other things behind in the wall. It can also measure electricity activity, like if you have electrical cables behind the wall. And there is also a sensor who measure the temperature on the surface. So by measure those things, it's possible to find more things than just the geometry. Sometimes you also would like to know where you have the studs in the wall. You would like to know where you have the water pipes or the electrical cables and so on. And those are possible to find when you use this sensor stick. When you have the glasses on and you use the sensor stick, you got the menu, which is shown here, visible before you, in front of your eyes. So you can see when you measure if you have high value on capacitance or electricity or temperature when you use this sensor stick, when you not throw it on the wall, but touch it on the wall. So more. And those results from the sensor stick can also be addressed as different colors on the point cloud. So this is, again, to the right in the picture, is from the office, again, where the sensor stick, you can see the different colors as a lot of dots, is where the sensor stick has been dragged on the wall's surfaces. So in this case, we can see that we probably have two studs behind this wall, because we have an area of green and almost red dots, which is placed like you have vertical studs. And at the same time as you got those colors, you can also have the information on the menu if you want to. Once you have this, you are possible to create what you see, because you would like to store this, so you could have it as an IFC file in the BIMS platform later on. So when you have the glasses on, you can see the result from the sensor stick, like different colors and dots. And by that, you can use the menu in the AR glasses and like write studs. So you just point with your finger and write the studs. In this case, and write 3 studs on the wall, and you can see they are not correctly placed because it's a bit difficult to have them in correct place at once. So you have to align them, like move them and rotate them so that they come in correct position. And once you are satisfied with your creation, you have the possibility to create an IFC file that you then download to the BIMS platform so that you can have it with your other drawings. If you have questions, so please write them in the chat or let me know in other ways. I have just a few more slides about this equipment and this tool, what's new and what is already existing. The existing equipment, which haven't been developed in this project, is the laser scanning equipment and also the used AR glasses. In this case, those are called HoloLens 2, which is AR glasses produced by Microsoft. Those are already existing. And what's developed in this project, it's the sensor stick, where all those meters are combined in the stick, and also the software, which is on the HoloLens. We have called the software Polytech, and it's a Polytech app within the HoloLens that is used. Those are the two things that is new and developed in this project. You can see on the left figure with the hand, it's how it looks like when you have the glasses on. If you fold up your hands, then you have the menu in front of your eyes. So in this case, you have the menu of different point clouds. So you can select which point cloud you would like to download to this room where you are inside. We were in Poland at your demo site in beginning of February this year, and it was a nice trip. And I would like to thank you, Alexander, for your hospitality, where we have the possibility to demonstrate and check the toolkit. So when we were at your site in Poland, we made a laser scanning of an apartment on the demo site, and we also used the sensor stick to map and see some of the walls and so on. And we also created some IFC objects, not an IFC file of the whole apartment, but object, because we have we have only 2.5 days when we were there, so we did most of it was demonstration how it worked. Okay, that was my last picture. There is the contact details for me if anyone have questions after. Otherwise, please, if you have questions.
So, hello everybody. My name is Konstantinos Tsatsakis. I'm coming from Switchfire, an SME company based in Cyprus. Switchfire is an IT company, and as part of the activities performed in the project, we developed the BIM4EEB application, an application targeting end users of the building, which are the owners and the inhabitants of the building, on a way to examine the potential of collaboration with these two business stakeholders during the renovation process or post-renovation process. So the overall objective behind the delivery of the BIM4EEB application was to enable building inhabitants and owners to get access on the contextual information of the building environment. So in the project, we installed different type of sensing equipment and measuring equipment in order to gather information that is required for different purposes and for different stakeholders. This information is always accessible to the BIMS platform, and thus one of the use cases that is of interest for the future is how this information will be made available for the occupants of the building, then users that are actively enrolled and participate in the building environment. So for this, we have to consider the way that this information is made available. And this is done through the BIM4EEB application, where we have developed dedicated views where the users can access information in real time, but also historical information having to do with the environmental conditions, temperature, humidity, luminance information that is gathered from sensors, or even further energy-related conditions, which has to do with electricity and other energy type consumption, which is also tracked by the relevant equipment. Another functionality is to provide a mechanism that will facilitate the building occupants to establish a comfort environment at building premises. And for this, in order to extract this information, we need to have a feedback from the occupants. So we're providing a view on the system that enables the users to provide feedback through this application, setting the preferences or non-preferences to the current environmental conditions. So the users for temperature and humidity for temperature and luminance can express the level of happiness or unhappiness to the current conditions. This information related to the context environment of the building is mainly related to the current status of the building. I mean, at any moment, this information is visible for the building occupants. Another type of information and another view of the application is the contribution of the building occupants during the renovation-related processes. So we can assume that we can provide an interface to the building occupants in order to be more active during the renovation processes. For example, when there is a renovation schedule, the typical process is that the constructor is coming to a discussion with the manager of the building in order to plan the activities without taking into account the feedback, I mean the availability of the building occupants or the disturbance of the building occupants. In order to progress on this step, we have delivered an application that enables building occupants to get informed about the different steps of the renovation process, therefore to get access on the different schedules that affect their disturbance mainly. So we deliver this, we analyze this, and we provide a personalized view for the occupants in order to get information about specific activities that are running in the building environment, giving also the possibility to the building occupants to negotiate some aspects of this renovation schedule. So if people are not interested for a specific day or for the duration of the renovation activity to take place, we give the possibility to the users of the application to define their preferences through the application and therefore renegotiate with the constructors the renovation processes that are to take place. In relation to this, another functionality that we're offering, it has to do with the information of the end users about safety and security conditions. It is a typical process when there is a renovation activity that's taking place, and that there is damage in the building, that there is some material that is, may raise some safety concerns to the occupants. And thus we give the ability to the occupants to get informed about these conditions through a notification mechanism, where the users are getting messages and getting notified about conditions that are happening, abnormal conditions that are happening in the building environment. Of course, this functionality can go post-renovation. I mean, even after the renovation processes, the building manager of the tool may use this functionality in order to notify the building inhabitants about specific conditions that are running in the building environment. A very last functionality, in order also to close the list of functionalities, is giving the possibility to the building occupants to provide updates on the specific conditions of the building environment. This is a main bottleneck in state of the art now in the current situation, because the typical process of the BIM management is okay. There is an initial building information model, which contains information about specific attributes of the building, which may change as the building evolves. And of course, the owners of the building, the occupants of the building, are the ones that have a clear, understanding and knowledge of what's happening in the building, and therefore they can actively contribute at providing information related to specific attributes of the building. So, for example, if there is, when the time comes to the operation of the building, it's a typical process that there is a reinstallation of some of the equipment. The user may install additional HVAC systems, for example, air conditioning systems. And this information is very critical to be part of the building information model in order to have a concrete model of the building. Therefore, we give the possibility through this application to the building occupants to enrich the building information model by providing information about specific attributes of the building. In the project, we have limited this functionality for the users to provide information having to do with energy devices. So if there's a new installation of an HVAC system or a domestic hot water system, so large consuming devices, the users are prompted to update the information through the application. I will now go to a demonstration of the application. So we have set up a test account here, and we have already logged in. I will show you later how is this functionality in order to show you the different features of the application. On the left side of the screen, you can see. Can you see the screen first?
Yes, we can.
Okay, good. On the left side of the screen, you can see the different functionalities that I was presented before. So I will not go into the details of each one of them as I presented them before. I will stick to the different views of the system. So through the My Overview tab of the application, the user gets insight about the indoor environmental conditions of the building environment, getting insights about the different contextual conditions, information about the temperature, humidity, luminance from different building zones, either at apartment level or for specific zones of the building of the apartment is available for visualization. In addition, information about the outdoor conditions, as gathered from external weather stations, is available and also visible to the users in order to get insights about specific environmental conditions. As stated before, a user's interaction is supported by the application, and thus the user of the app may go and select a specific, a specific level of happiness, let's say, of preference based on the current conditions. So if the user is happy or not happy about either the thermal sensation or the visual comfort at this current moment, the user is prompted to provide feedback for the current condition in order to express a level of interest for the environment that he or she is placed. Along with real-time information, as commented before, access on historical information is available, and the user can select a specific period for analysis and drill into the details of environmental conditions for temperature, humidity, and illuminance, as well as CO2, where data are also available for monitoring. Along with environmental conditions, access on energy-related data is visible through the dedicated view of the system. The user has access on the time series of information about energy consumption. Insights can be extracted by monitoring the time series. Aggregate statistics are also visible for the end users. Also, time period statistics, time filtering is also visible, where the user can quickly access the aggregate consumption at specific time granularity. For example, here by having the week statistics, we have per week the aggregate information about consumption, and thus quick insights can be extracted. As you can see here, there is a deviation on the week consumption level, and thus the user is getting informed about the trend of consumption during a specific period that has been selected for analysis. As mentioned before, we have also the renovation process related functionalities, where, as you can see here, there is an indicative set of renovation activities that have been defined by the constructor of the building. And the user is prompted to get insights about the period, the duration period for this activity, the total duration in days, the allocated zone, the status, past or foreseen activity, and action that may be performed. For this case, we have past activities defined here, and thus there is no reaction that can be performed by the user. But the idea is that the user can get into this view and modify, renegotiate specific parameters of interest for the renovation process. Related to this is the safety and security events that were commented before, where the user is getting insights about specific safety or security conditions. There is a typology based on the status if we're talking about finished events, ongoing events that are happening now, today, or upcoming events that will happen in the future, as well as a level of importance that is defined by the stakeholder that is triggering the event. If it's a critical event, if it's not a critical event, and if there's a situation that is, of high importance for the building. Also, the user can report a safety incident. Apart from getting insights about safety incidents, the user is prompted to provide information about a specific condition. So if you are an inhabitant and you get out of the building and you get a view of, let's say, of something that has been damaged, the user is prompted to go through this application, inform by providing a nomenclature here, if it's a safety issue, if the material-related issue or process-related issue. So there is a typology, standardized typology that we're using. Or, for example, if there's a services, an electricity outage, or whatever is the case, and if it's a level of importance, and providing a title and description, or even possibly uploading an image, the user can notify a third-party stakeholder. The most typical case is the building manager, to get insights, to get informed about the specific condition, and therefore proceed with relevant actions required in order to mitigate this risk. Functionality related to the BIM annotations, how we can enrich the BIM model. We have the 2D representation of the building. The user is prompted to select a zone in order to get insights about the zones, or even further, as commented before, to select the zone of the building and provide information about a new installation that is to be placed at the building environment. Apart from the functional views as were presented before, we have the generic views where localization of the application supported at the different countries. So we have the translation to the different languages that are supported in the project. We have the list of zones that are reported, as commented before. This test account contains the full list of apartments examined in the project. Details about user profile can be defined here, where the user is prompted to provide information about the type of the user and the age group that are mainly statistics related, for better profiling of the users that are enrolled in the project. The user may delete the account or update the password for logging into the project. And also we have a view that contains the full list of, attributes of entities that have been associated to this apartment, which is mainly useful for the end user in order to define the personal name if they want to change the type of, the name, the names for the different types that are examined in the project, in order to have a more friendly view of the different names that are visible through this application. I will log out again in order to show also the login functionality of the application. A username and a password is provided to log in. Of course, we have also the sign-up functionality at the beginning, which is very important as a process, where the user is prompted to define a username, a password, and also a user token in order to link the specific user with a specific set of data that is contained to the BIMS platform that was presented before. So the BIMS platform is the one that contains, let's say, the user's database. The full list of users that are associated with specific zones and therefore with specific data. And therefore any other application, and thus the BIM for occupants application, is prompted to exploit this linkage by providing the unique token that is available from BIMS platform, copying this information to this application, and then being able to retrieve the personalized data for each user that is enrolled in the project. Going back to the very last slides of the BIM4EEB application, apart from the front-end functionality, let's say, apart from the view of the BIM4EEB application, in the background is, of course, an engine that does perform an analysis in order to make this information visible for the end users. So there are specific components that are responsible to handle all this information. So sensing data are coming in a raw manner, and therefore processing of this event is required. For example, one type of processing that we're performing, apart from descriptive analytics that has to do with some statistics over data, is the engine that we have in order to extract the comfort profile of the user. For this, we take into account the actual environmental conditions, along with the feedback that has been gathered from the occupants. We analyze these two types of events in order to extract some statistics having to do with the preference and non-preference of the users under specific environmental conditions. And then we make this information visible to the users as a notification about the level of comfort or discomfort of the users under different temperature or luminance conditions. Another view another type of analysis that we're performing also in the project has to do with the analysis of occupancy data. We gather in details about occupancy as extracted from a sensor that is installed in premises. We have further analyzed this event, so occupancy-related information is further analyzed by aggregating this information in order to extract, let's say, lakes of data, data lakes, where contain occupancy events. From this analysis and extracting, and removing the outliers that we have on the data, we can extract the typical patterns of occupancy, information that enables us to better understand the level of occupancy at the building environment. The important for this is not to track, we don't aim to track in real time the occupancy level, rather to extract occupancy profiles, so aggregate statistics of occupancy, that can facilitate us to better simulate the operation of the building. So the typical occupancy profiles that are available nowadays are mainly from average statistics, following the analysis of a large volume of buildings. But the literature shows that this aggregate statistics, of course, the aggregation does not fit to each case, and that it's better to have a better estimation of the occupancy level per building in order to have a more accurate profiling of the building, and therefore more accurate simulation of the operation of the building. This is a screenshot about the renovation scheduling and safety alerts. I demonstrated this in real life, so there's no need to discuss more about this. The only important thing that has to do here is the fact that, apart from the information, the notification scheme is available. So at any moment, the user is prompted to press this. I have it logged out now. In any case, in any way, to press the button of this bell in order to get insights over the history of events associated to scheduling or safety alerts that have been triggered, and therefore to get quick insights about the specific events that have taken place at the building environment. And that was the very last part of my presentation.
We have one comment from Mr. Zawistowski. He's saying it was very interesting. Okay, so the last part in demonstrated tools presentation part will be the BIMS-CDE platform, and it will be presented by UCC representatives, which is Ion.
So, BIMS-CDE tool is a tool made up of a few different components. So it's there's the constraints checking tool, there's the performance evaluation tool, and then there's the data management tool. So we'll go through the data management tool initially. The one part of the data management tool is the sensor tool. So here we can connect to the sensors on the Polish site, and we get a list of the different apartments that are available. We can select the apartment and the sensor that we wish to upload into our system, and currently that's set that it will upload 24 hours of data from that sensor into the BIM-CDE tool. So then another import tool in BIM-CDE is that you can upload an Excel file with specific data that you want to upload, and then you can map it so that it's uploaded into the database in a standardized way that you've set. So you could, if you wanted to keep setting uploading the two data in a similar way every time, that you could configure that, and that it would be uploaded into the database like that. So here you have motion data being imported in so it's just basically the date and the motion readings of this specific sensor. So that can be uploaded into the database, and then all this data can be viewed in the performance evaluation tool, which we'll go into more details shortly. Now on the screen, where you can just select the data that you have just uploaded. So that was the sensor data that has just been uploaded to the system, and you can view that and analyze it as you wish. So we'll be going through that this process in more details shortly again. So it'll just show the data here from that. That was a CSV file that was uploaded to the system. So you can see all the motion there in that data file. So then another component of the data management tool is the IFC ontology. So you can select an IFC file to analyze, and it will then select out all the different components that are in that IFC file, and they can be searched and sorted as you wish to view what's in the CSV file, and to select which one you want to view in specifically. So then, if we move on to the performance evaluation, is the next tool. So here, if we look at the different sensors, so we've just done a search here for Polish, for all the Polish sensors from the Polish demo site. So you can see the list of them here. So there's two different ones there for the apartment 5. There's, I think, at least 3 for apartment 8. So here we want to compare the temperatures in a few different apartments. So that's under the multi-sensor, and we'll also select the outdoor temperature just for comparison. So we select the chart type, which will be a comparison chart type, and then we select what we want. So these are all the different variables that have come in with the sensors. So there's temperature, humidity, luminance, UV, motion, and then it goes on to the temperature 2 is related to the next apartment, apartment 10. So here we're selecting out just the temperatures, the 3 different temperatures we want to map, and then we select the data range that we want to show it. So this would be comparing these 2 apartments, the readings for these 2 apartments. The second one is probably the clearest. So you can see that one apartment, they were both about 18 or 20 degrees in the apartments, and then that it was sub-zero here for during the night, and increased up to about 6 or 7 degrees outside. So yeah, and you can select in and view specific ones that you want to. So then if we just select out one of the apartments, and we select the temperature and humidity for each of them, we can just check the thermal comfort values for this apartment. So this is analyzing this data, and we'll just see it mapped here. It's probably, you can switch off, but the lower graph is probably the so we can see that the average humidity would be around 50, over 50%, and then the temperature is somewhere around 20 degrees Celsius. So then there's this a thermal comfort calculations tool. So this, if it's in orange, that means it has been calculated from the readings that have been selected above. So the average temperature for that day was 20 degrees in the apartment, and the 54% was the average humidity. So this would be, these are the thermal comfort calculations from the Berkeley University thermal comfort tool, PMV and PPD. So you can see that it's not reaching the ASHRAE standards for thermal comfort in that apartment for that day. So it would have to be changed to 21 degrees. So the temperature should be increased by 1.5 degrees to reach the ASHRAE standards that had been set. So that's just for that apartment for one day. Then if we again, if we check, I think it's motion that you can select in on the motion sensors is this one, and to compare to, and you can see for that day that the person was out for most of the day, and then at home for some time, and then to sleep then again. So I think there's another apartment is analysed as well, and again, there isn't loads of movement, but you can see the person is out for most of the day, back for a small bit, and then probably asleep. You can also check, compare the relationship between two different variables if you want. So we've done comparisons up to now in the examples, but if we want to just view the relationship, we'll say between power and energy, we can map those against each other and see if there's a correlation. So you can see all the variables there, the data and how it corresponds, and then you can select out if there's any outliers. You can remove any outliers. So we'll say if we want, it has highlighted these possible outliers, but if we want to keep most of them and just remove the last two of the outliers, it'll redraw the chart, and then you could save the data if you wish from there. So yeah, so that's the data again. So the next we'll go on to the M&V tool. So here we set up temperature and humidity, and if we want to set a filter of the illuminance, there you set up. This is setting up a baseline model for a site before the retrofit, we'll say, and then you click to view, and it graphs the temperature versus humidity. Then you can set up your models, and it will graph those models, and then you have to click whether to accept those models that you've set. So then once those are set up, you run a linear regression model, and you set the confidence interval that you wish, and it will then graph the data and the scatter plot, and you can view it in time series. You can view the data specifically that you want, And then the last one is the model details. If you want to view those details, then you accept the model that has been calculated, and then you move on to the reporting period. You set up the dates you want for the reporting period for the data, and we'll just move it on. Again, you can view all the scatter plot, the time series, and the data if you wish, and it will plot the data. And then if there are any non-routine adjustments that need to be made to the data, you can do that in the last section of the tool. So the last section of BIM-CDE is the constraint checking tool. So this is where the HVAC systems and the different components, so lighting components and sensors, optimum locations are suggested for those components. So you can select out, set up your project initially, and select out the different zones, the floors and the zones you want. So in this demonstration, there's 4 different zones set out, and you set that out. Then you set out the components that you wish to process. So in this example, it's HVAC, sensors, and lighting, and you select out the different specific components that you wish to add to the system. So for each of the components that you wish to set it up for. So they're the sensors for CO2, humidity, and temperature, and you want to select the specific products. So then you save and continue on to the next, and it will suggest locations. So for the HVAC, it selects the ducting and the diffuser points, and similarly for the lighting and the electrical system, it'll set out where the lighting units are and then the wiring system, and then it creates a report based on that, where the suggested units, the placing of the suggested units is drawn, and then it lists out the different quantities of the different components, and you can create a report there. So then, just to go back to setting up the actual the floors and the zones, this is where you'd do it. So you've to draw out the specific zones that you wish, and that will then be processed. So that's how you do it, and you set the zone type, and you save the zone, and it'll then calculate. So that's for setting it up, and you can set up the different changes, the zone area, the lux level you want, and sections like that. You also need to set where the ducting will start, where it comes in that floor, and similarly where the electrical board is for the electrical and the sensor and the lighting systems as well. So that's it. Then the final section of the is the BIM. We have a 3D model viewer as well, so you can view it, and if you want to take snapshots from the 3D model viewer, that can then be used in the constraint checking tool. That's where this is done. So you can zone in on a specific floor or components that you wish from the IFC file. Yeah, that's my presentation. So yeah.
What is also very important, you can notice that whole toolkit is cloud-based toolkit, so you need only the internet connection and web browser to access the tools. So I think this is also a big strength of the toolkit, that it is cloud-based. Okay, so we are finalized with the point 3 of today's workshop with the toolkit presentation. We are probably a bit before the time, so the next one we can spend probably 10 minutes, not 5, like it was set it up in agenda. In this part, we will ask you for the feedback inside the dedicated survey. I will use the chat feature in Teams, and I will send you the link. You can access. You can access the survey using the following link. And your feedback is very important for us, also for the project evaluation, for the project results. So just a second, I just copy the link. Of course, you can also try to use the barcode on the screen, probably using your mobile phone, but also you can find the link in the chat. So probably we'll do some kind of short break, about 10 minutes, for the survey feedback. And okay, thank you very much for your feedback. If you didn't manage to leave your feedback, we will propagate this link by emails for the guest who has registered to today's workshop. So if you didn't succeed with the survey, don't bother. We will propagate the link by emails also. Okay. In the conclusions part, in the beginning, we as a Prochem, we would like to thank you. Thank you all the guests for their attendance on the workshop. Thank you for your feedback in the survey, and what is very important for us, also related with dissemination activities of the project. Please follow us on this. Follow us in the internet, or follow us in the website, and of course in the social media. So you can find very nice website for BIM4EEB project. We have the latest news about the project, about the development. We have, of course, all the tools described inside the dedicated chapters. So the website is very, very interesting, I would say. And please follow us, and to disseminate the BIM4EEB project. In the end, I will ask you: do you have any questions, any comments? Not. Thank you again for your attendance. You can, like I mentioned, you can find us in the social medias and website. And thank you for your time. It was a pleasure for me to present the Polish demonstration process in the BIM4EEB project. Have a nice day.